Good morning. And I see Simon yesterday made a good job selling this presentation, whoever was there. So I'm going to speak today about what you see in the slide. I don't like reading my slides so much. But I'm going to talk about hybrid applications, meaning applications that use Qt and WebKit. I'll explain why we need it, what it's used for, what it's not used for, and how to use it. Now, before I start the actual presentation, I wanted to know a little bit about who I'm talking with here. How many of you guys develop mainly for desktop? Okay. How many of you develop mainly or also for mobile? And same question, et cetera, for embedded, industrial embedded. Okay, so we have mainly desktop crowd. The reason why I'm asking is that this is a technology that can be used for all three types of development. I've been using it mainly for embedded, TVs and such. But since the crowd here is focused more on desktop, I will explain the technology more in a desktop context. So my name is Noam Rosenthal. I work in the San Francisco Redwood City office of Qt. I'm a software architect, which means half the time I do actual real-world coding, and half the time I pretend to know what I'm talking about to other people, which is what I'm doing here. I've been working with Qt and with Qt and mainly with customers for the last 3 years. And in the last year, I've been also contributing to the WebKit project, mainly around making it hardware accelerated in the CSS realm. Well, let's start with a real question. What's the point of web applications? Native applications can do so much. What's the point of web applications anyway, right? So some people talk about the standards and those kind of things. For me, what's important about the web application is the portability and the zero deployment of it. So if you talk about mobile, for example, then WebKit is on all the mobile platforms today, all the mobile smartphone platforms, in Android, iPhone, and on OS and RIM, plenty of others. So the web platform is there no matter what the platform is. Same with desktop. Even if you're on Linux, even if you're on Mac, the web is there in different forms of shapes, but the main idea is there. So the portability that the web creates gives something that maybe Qt was the only thing that was there to give that 15 years ago. In a different way, of course, without a native look and feel, etc. Also, there are so many web developers around. If you start a company and want to hire people with web experience are much easier to find. There are, I think, 10 times more people who are familiar with JavaScript than people familiar with C++, and JavaScript growing, C++ shrinking, which gives all of us a better job security, I guess. Oh, I have an extra space there. What's the point of native applications? So web technologies are great, but they can't achieve everything. Because in web technologies, we have to agree on a lot of things with people doing Firefox and people doing WebKit and people doing Explorer and Opera and web developers. And everyone has to agree on what we do. Agreement takes time. And sometimes we want to push the limits and do things ahead of time. That's one reason. So For example, I want to have an application with a big offline database, like a 100 megabytes database. I don't want, and it's offline. I don't want to put all that into a web application, even if it's offline. I would want to do something native with it. Also, if I'm writing if I'm talking about desktop, then if I write an analysis program, like an imaging analysis program, I don't want that algorithm to be done in JavaScript or the web. And on mobile, if I wanted to write a guitar tuner, right, then I need a fast Fourier transform algorithm that goes over raw audio data. JavaScript, handling with JavaScript is a very nice, I guess, college experiment, but I don't think it will work for a real app. So native applications are needed to push the limits and to do things that the web platform just can do. So why combine them together? I mean, there's web for the web, and there's native for the native. So this is a bit of enjoying both worlds, like going to sleep at 4 and still waking up without a hangover. Not that I did that. But so when you combine native and web together, you're still really in a context of a native application. Your application is deployed natively. It can do anything a native application does. But part of it is as portable as the web, can run on different platforms than yours. If you write for platforms, for example, that don't support Qt, like the iPad, you want to write a tablet application that works on Windows netbooks and on the iPad. You can probably use the Qt port for iPhone that's not supported by us, but if you want to use things that are supported by us and work very well, then WebKit you can use on both platforms. And then the C++ layer underneath, you might have to rewrite some of it, or just the connection part with the C++ library. So it gives portability for most of your code and lets you ship the rest of the code. Also, this is about performance in a way. How many of you had to work around Qt performance issues? Not that we have any. Oh, not that many. Good. Or other performance issues in platforms. Right. So sometimes you need to do that to ship, right? Sometimes it doesn't matter how beautiful your code is, how right it is architecturally. I say that nasty hacks make the world go round. So combining them together lets you use the web application, get the portability, but still get the nasty hacks that make your customers happy because you ship in time. How does it work? So now instead of showing something very, very fancy or very complicated, I'm going to start from scratch, from an empty Qt creator, and build a small hybrid application from scratch with you. If anybody wants to use our computer to try to replicate it, you're welcome to do that. And what I will show is, because we're more desktop-oriented in this room, I would show a desktop application that has HTML UI, but behind it has a C++ application, a C++ enabler that does a hardware-intensive operation. I'm not going to write a real hardware-intensive operation, but I'm going to mimic what that means in terms of the hybrid application. So what we're going to write is a text analyzer application that gets a list of strings, whether it's large or small, and can return. And when it's done processing, it will the UI will notify the user how many characters there are in all the strings together. Now, this wouldn't be process intensive if the list was small, but you can imagine how this can be scaled. So I start with a regular application. Can you see this? Can people see this well? Right. As you see, I was working on WebKit. Call it hybrid DevDays. Munich. I make this a regular widget application to make things easier on myself. Now, the first thing I do when I create a hybrid application is take care of hygiene. So by hygiene, I mean make sure I have the web view right, make sure things can run on it, make sure all of that compiled. Just get all the boilerplate stuff done. Sometimes when you write hybrid application, the boilerplate is what gets you stopped, get you stuck. So here I'll just go through it. So first of all, I will need a WebKit in the profile. I will need a QWeb view and possibly a QWeb frame. And now instead of showing widgets, I will create a web view. Now this would probably not do much. But it is an empty web view. Now, I want, like you see, I'm going step by step. So the next step would be to just load a regular HTML file in it. To make things easy on myself with deployment, I will put that HTML file in resources. And I would add a new file. I would call it index.html. And right now it will just show a regular hello world. And this is again the boilerplate hygiene stuff. So I create a prefix test, and I would add a file to it, index.html. I can use the QRC protocol to load files from resources. And then I see that it works, or if it doesn't work, I can check why. So I have a regular hello world just with HTML. Now, you can imagine I can put any HTML here. I can load files from the network with that web view. So if you go later today to Benjamin's HTML5 Beyond the Buzz presentation, you will learn more about the HTML5 features. I'm not going to go into that in detail today. Okay, now I have the web without native kind of set up on the side. Now I want to create a library for analyzing text. So this is a class. I will call it, they're a really creative name, text analyzer. And this will be a queue object. Now, queue object is a very important part of why all this works. And you will see in a minute. So how many of you use Qt object? Okay, good. Just checking that everybody's awake. Okay, so we will create a simple text analyzer class. It will have a slot called analyze text. It will get a string list. Okay, makes sense. It gets a list of strings, analyzes the amount of the total characters in all of them. Now, we want it to give us a callback when it's done. So this will be a signal. So the signal will return in an argument the total characters in this whole string list. And we want to monitor progress. So we'll add a queue property. It will be a real. And we'll have a function get progress. Yes, I know, putting a get is not Qt style, but I think we can handle that. So now that I have the signal in slots, let's put some functionality into this. Now, this is not important enough to show hybrid, but it's important for me to show you that this is all from scratch and make you feel like it's easy to do, or that you can come out of here knowing how to do this. So we save the QString list to the list. We save an index of where we are now. And we'll, the way we're going to do this is we're going to have a timer that every second analyzes the next string. Because then this emulates the behavior of a slow or a process-intensive background operation. So we'll have a private slot. Analyze next. So now I implement all of this. And let's save a queue timer here. Probably need to include okay, so we get a list of strings. So we set the index to 0, we set the list of strings, and we start a timer once every second. Now, in the constructor, we connect the timeout to analyze the next string. Now, analyze next string is going to check if we're done. Oh, I should probably save the total characters as well. So, if we're done, we're just going to emit the done with mtotal and return. Now, this is an early return, so here I can do and in get progress, I can make sure I return the progress, which would be the index divided by the size of the list. And I can do division by 0 protection. As you see, I compile each part separately. I want, because hybrid applications contain many moving parts that connect together, I usually actually would create a native test for this before connecting it to hybrid. I will not show it here because I'm sure you know how to do this, but that's how I usually go about using hybrid, because then you test the library separately and the hybrid part separately. And now to the hybrid part. I want to expose this text analyzer to a web application. So I include textanalyzer.h, and I instantiate one. Now, there's the magic function. It's called make everything hybrid and work and be really nice and have no bugs. But really what it's called is add to JavaScript window object. Add to JavaScript window object. I give it the name. Text about hybrid text analyzer, and it's a queue object. So I called it my analyzer, I guess. Now another thing with this magic function has to do with web security. The thing is this: every time you switch between web pages, we clear all the native objects that you add to it. That's because if you go to some untrusted source, we want the application to be aware of that and decide for itself if they want to introduce those native objects to the untrusted source, so that those sources wouldn't jeopardize security. This is all based on your application. The application has complete control over what to do there. But to really make sure that this object is always connected, I will have to create an object that does that. So I'm creating a slot called refresh page. This object would need to have a link to the web frame, a pointer to the web frame. And in this case, let's move text analyzer here. And for simplicity, we'll make this a child of the web frame. And here we would connect this magic signal, JavaScript window object cleared. This is a signal for your application security. So every time you switch pages, this signal will be called. Refresh page, maybe not the best name in the world, but it would do for now. And here we will instantiate this hybrid connector. Now, to get this running, we would need to include main.mock, because we put an object in the implementation file. And we will need to run qmake again. Now, let's see why that wouldn't work. Well, it does compile, of course, but let's make sure we actually get access to this object. So we called it hybrid text analyzer. And when I add to JavaScript window object, the place where this is available for me is, of course, JavaScript. So on body on load, I can right now check if this object is available for me. Hybrid text analyzer. I can do window dot, but that's superfluous in web. Now, let's see. So I started and I have an alert, text analyzer, name equals nothing. If I didn't have that object, it would say undefined. Undefined is also what it would say if you just run this in a browser. Okay, so now I know I have my object. Now it's time to write a little HTML UI that will manipulate that object. So remember, this object gets a string list, right, as a parameter. So here I will create a string list, except this is JavaScript. How do I create a string list in JavaScript? I create a JavaScript array, just a regular JavaScript array, and make sure it contains strings. Okay, so I have a string list. Now I can get this string list from an online source. I can get it from user input. You get the point of this thing you can do with JavaScript to get this kind of array. And I want a little button that allows me to start analyzing this. So and I create an doAnalyze function. Remember, we have the object, right? Hybrid text analyzer. And it has a function, analyze text. It gets a string list, but here I can just pass it my JavaScript array that contains strings. Analyze text. I didn't understand. Oh, typo. I can't hear very much from there, sorry. So, right now we can test that it doesn't crash, but of course it wouldn't give us any result, right? So, the other thing we want to do is make sure we get a response when this is done. So, we have the signal analysis done. As you see, I'm using a lot of copy-paste here. This is important because the names have to be exactly right. So copying the name from here, you can copy it here. And I use the magic word. What's the magic word in Qt? Right. Connect. And the nice thing about JavaScript is that it's a functional language in a way. It has functional attributes at least. So here I can just declare my own function. And it will get the total as an argument. And let's create a div here that will show us the total. This is a nice Qt WebKit function from JavaScript called query selector. It's actually in WebKit, not just in Qt WebKit. But I can easily select an element by its ID or by its classes or by a whole bunch of attributes. So I can take the argument coming from C++ and put that into JavaScript. Now, so just to make us find errors a little faster than 5 seconds. For now, I'll just do 2, and later I'll add the rest. And now let's see if it works, and if it doesn't, I will introduce Web Inspector, and we can see why. Yeah, it didn't work. I need to personalize. Web Inspector will not show me that. 10, so 10 characters total. This works better than the last time I did it, this demo. Okay, so we showed how we can run a slot and get a signal back. And there is a type, kind of an automagical type conversion between WebKit and between JavaScript and Qt. It's not automagical. It's actually a whole bunch of lines of code that actually check what you have and check what Qt expects and makes the best conversion it can try. So now we also want to check what the progress is. So we'll create another div. Oops. Let's say that every half a second we will poll for the progress. And first of all, we'll have a variable. And called it progress, but copy paste is a good practice here. I think you can do this in JavaScript. Now let's see if this works. This actually did not work. Ah. Very good. Now this could be a problem in my text analyzer or here, right? I'm glad we finally got to some trouble because we can see how to solve them in real time with an approach like that. First of all, we make sure we have enough. And we can, why don't we, instead of rounding it, we just show the progress to see if we get if the rounding code is maybe wrong here. Yeah, so it looks like I'm getting a wrong value from C++ function. Yes, here is get progress. I don't need to connect it to get progress. I need to connect it to progress, which is a property name, which then connects to the get progress function. So here I can just use qdebug, like in any other Qt project. This seems right. seems right too. I was using set timeout instead of set interval. That's the problem here. Set timeout is like a key timer single shot. I've been doing C++ too much lately. Okay, so this shows the main concept of hybrid. You can use signals, slots, and properties. Now, let's say you want to pass through to WebKit something a little more complicated than just integers or a list of strings. So let's say instead of total here, let's say that instead of total, we wanted to return a JavaScript object, like JSON, that included real data that we can use in some structural form. So it would look in JSON something like this. Okay, it will be an object with a few JavaScript properties. So in this case, we use a class called QVariantMap. It's really a QMap of a string to a QVariant, which is very similar to JSON concept. So here in analysis done, instead of returning an int, I have to return some data. Let's call it count. And I should probably include that class. Let's see, this compiles. Now, the argument to the signal would be data, and the total will be it's just data.total. The same string I use here, I can use here as a child of that JSON object. Instead of this, I can just do data.total here. So the same thing, just with a compound JSON element. So I'll return a little bit to the presentation, and then we'll have lots of time for questions. This is about how it works. Now, how does this relate to Qt Quick? You heard a lot about Qt Quick, I'm sure, in this event. Because of JavaScript, it might seem like using Qt Quick and using hybrid or HTML is similar. It is similar in the way you go about it, but it is very different in what you're trying to achieve with it. With Qt Quick, it's about productivity and writing cool UIs on platforms that support Qt very well. This approach is not about necessarily that kind of productivity. It's about the portability with other platforms as well, and the use of technologies that are common. When should you use this? When you have a need for portability that comes together with a need for some native hacking or to connect with a native UI. For example, if you guys all know the iTunes application, right? Or Napster or any other of those music stores. That application has a tree on the left, and it has a music store in the center, and it has a player on the top. Now the tree, you don't want to write custom in QML or in HTML even. Each time you write an application like that, you want it to look like the platform, and you want something robust that works. QWidgets is very good for that. For the player on top, it's very custom, needs to be very dynamic, very fluid. QML is good for. In the middle of the music store, it's fresh content coming from a server all the time. So when you have a server, standards really helps you, because you know that even if the code there is older than the runtime you have on your machine, you know it will still work with the right fallbacks. Also for dynamic content, HTML is a very good tool. So when you have an iTunes style application, the store would be best written in HTML, and that's actually how it's done today by iTunes. When they started, it wasn't. It was just the custom formats they were using, and later they moved to using WebKit for that. When should you avoid this technique? Basically, you should avoid this technique when you don't need its benefits. It kind of sounds trivial, but if all you're writing is really, for example, a mobile application for a particular platform that already supports Qt, and you want it to be the best it can get, this will not help you at all. This will just create overhead because you have to deal with the standards, and you'd have to deal with the hybrid mechanism that, as you saw, is not very hard, but it's unnecessary. Then if I'm just doing that, this would not gain me anything. Another place I wouldn't use it is if my UI is very, very tied with the native data. If I need a lot of signals and slots and a lot of connections and a lot of initialization of objects out of the UI, doing all this in hybrid becomes quite hairy, becomes quite difficult, and you get into object ownership problems and other issues. If you have an application that's like that, I would highly recommend to do it just native. The other side of it is that if it's just a website, or it's just a Facebook reader or something, RSS reader, or something that just accesses the web and doesn't need native, then you can just use the browser or one of the runtimes, but you don't need to. Where do you start? This was included in Qt in 4.4. We have now added documentation for it. So now there is full documentation in the Qt 4.7. It can be found with the Qt WebKit bridge if you go to the Qt WebKit pages. I don't see the point of posting links on a presentation like this. Also soon to be integrated is a tutorial that does exactly what I did here. It also includes MultiThreading and shows how to utilize that for a real a more real-life application written by ICS, and we use it. Will be incorporated in our tutorials. So we have a lot of time for questions. And if there are no questions, I can show more tricks maybe. But
Actually, I'm using it for more than a year now, and I had a problem with a race condition in JavaScript.
Mm-hmm.
Now, we have a lot of web developers in the company, and I asked them about, hey, how do I get a mutex or something like that? They were just shaking their heads and said, hey, dude, there is just a single thread. It's impossible to get such a thing. But I was able to reproduce it, like was calling queue web page, execute JavaScript, dispatch a JavaScript event from there, and then all of a sudden a JavaScript function got called twice, or it got called simultaneously. Now, is this a bug, or is this intentional behavior where we need to work around?
It's both. No, but really, the way to use this with multi-threading, and I'm glad you asked this, is to not use the low-level functions like mutex, but rather to move the object that you're calling into a different thread. When the whole object moves to a different thread, and there was a blog post on Labs from Brad about 2 months ago, I believe. I think the title was somewhat teasing, but when the object lives in a different thread and its entire event loop is in a different thread, Q takes care of all that. And when you call C++ functions from JavaScript, when you call a slot, it will do the multi-threaded stuff and create an event and call it in the correct thread. And when you use a signal, it will emit the signal in the UI thread for WebKit. And properties you have to be careful with to make sure that the data is thread safe. I don't know more about the particular problem, but in a more bigger picture answer, I would use this technique with care. I would not use it for everything, and I would try to make sure that what I expose in C++ are actually systems that work very nicely and packaged to JavaScript in a very minimized way. You don't want like a whole bunch of tentacles from your native application going to your JavaScript application. It gets hard to manage. And sometimes, like there are a few, I would say, yellow flags you can, usually when I write hybrid application, and I don't know if your particular project, sometimes you have to do things like that. But the warning signs when you develop a hybrid application, one, you don't know who created the object. A warning sign is, for example, a class like my text analyzer that returns a QObject pointer, who releases it later. So that's one warning sign. Another one is if you have to do evaluate JavaScript. It's probably would make me think about what I'm using hybrid for. Sometimes there are other tricks to achieve what you want, like wrapping whatever you get from C++ in a different JavaScript function. But this really works well if you kind of go with the architecture of QObjects and just let it do its thing with the QObject threading and with the queued connections inside the QObject. I hope that answers the question in the general way I can do right now.
I have written a service application which is running as a daemon on Linux and a Qt service on Windows. And I'm asking myself, it is good to have this technique as creating a client application for having a user interface for this.
And it's very depending on the requirement of the particular application. If you're asking me if this is a good technique, yes, it's a good technique.
Well, I could also use Qt Quick for this.
Right. If you know you already have Qt on your platforms,
yes,
if everything is Qt based anyway,
yes.
And does your UI need to live on the server, or?
Well, it would be good advantage if it could be on another PC. Would be good.
Yes. So if you control your whole stack, then sometimes Qt Quick might be a better solution.
Okay.
But if you don't, or if you don't know, if you have some dual deployment issue where the server might be deployed separately from the client, then I would use this technique because of the standard. We know what's supported. There's very good fallbacks there. That helps when you have a server. With Qt and Qt Quick, the backwards compatibility and that kind of robustness in the format does not exist yet. But if you do control everything, there's no reason why not use Qt Quick. There are also features that are more related to how your UI looks like that make web a better choice or Qt Quick a better choice. Like if your UI is more content-driven, and what I mean by content, like you have a text that you don't know the length of the text, you don't know where it's coming from, you don't know how it's going to be formatted, and you might have images, and you might have other effects, and the way they're formatted together is by a set of rules, not by a set of fixed positions like a UI. In UI you design, and then you have fixed elements and with some UI rules. But in content, the rules are a lot more complicated. Like you have to say something like the image floats for the left or floats to the right. You have to say the margins and the backgrounds and the lines between the text, line sizes. If your UI is more like that, I call it dynamic content versus dynamic UI. So it depends on your UI.
Well, the problem is it's mainly a big tree view with many thousand items in it. Mm-hmm. So it's a big amount of data.
Right. For that right now, I would probably use widgets.
Okay. Thank you.
What you have shown in your example could also be done completely from the C++ side, because I could hook the link and I could access the DOM from C++. So what are the differences and advantages of each approach?
The advantage of this is that, for example, just a background, we've written this for a customer that wanted to have their UI in a server. And they wanted the least possible in C++ because they had update problems. They wanted to update very frequently. Actually, the customer is speaking right now upstairs. It's Netflix. So they wanted to do more frequent updates without having to deal with tool chains. So they wanted as much as possible in HTML. So this gives them that power without having to change C++. Also, I see this connection as part of the UI. The way I usually prefer to divide it, I see HTML as a good language for UIs and C++ as a good language for libraries. So I would write my C++ code as a library and HTML as a UI. Of course, this is for particular UIs. If you want a tree widget with 1 million items, C++ is way better than HTML. But that's how I would go about it.
Nokia have also are working on this Qt web frameworks.
Right.
How does that compare to the techniques you show here? Can you combine those techniques with these Qt web frameworks as well, or are there things to be aware of?
You're talking about the web platform and the Qt web runtime as part of it?
For mobile, yeah.
Yes. So the web runtime is a hybrid application in itself, and it provides like a common set of hybrid APIs that you can use apart from the regular web platform. And you deploy your application as a widget, which means that you don't have to write any C++ code. The thing about web runtime is that when it comes out, right now it's not available for developers. It will use the same techniques as this. So I can't really say much about stuff that's not released yet, but if you are considering web runtime, this is where you start, because this is supported now. It's supported on the N8 right now, because this works in 4.6. You can start with it, and later when the widgets come, and not the Q widgets, but the web apps come with web runtime, migration should be easy because the UI is in HTML anyway, and you just have to connect it to the default JavaScript enablers instead of to the ones that you provide here.
So you think it will be possible to write hybrid applications with that?
I think for now, hybrid application is more along the lines of Qt. It's like a Qt application that's written with web technologies. They both use the same WebKit, so all the HTML5 features are there in both of them. I don't think there's a plan right now to provide something like an embedded web runtime, to embed a web runtime view into a regular Qt application. But it might be something to consider for us.
What you showed here is very powerful. It's great. You've got a good connection between the JavaScript and the C++. And obviously the JavaScript and the HTML part is portable. But when you actually have to port that to somewhere where Qt isn't supported, what had you in mind there? Because it has to work somehow like the way the Qt didn't work and have these good connections. Is there other alternatives on other platforms?
Yes. If you take, for example, the iPad, okay, this is a sort of desktop, sort of mobile application. So the iOS provides a hybrid application support. You can embed a web view in a Cocoa Touch Objective-C application. It might be a little bit different. It's not compatible with what we do in Qt. But the way I would go about it, and I have been trying this at home and myself. So here I have the hybrid text analyzer, right? So here I can make a check. I can check I can check where I am, and I can obfuscate those platform differences. Now, does this create fragmentation? Yes, it does. But there is some platform fragmentation because we don't run on all platforms. And this allows you to use that platform fragmentation to get the extra you need from a platform. But this is how I would go about it. Embedded web view, 80% of your code is portable. And the rest, you do a little bit of obfuscation in the JavaScript code, and you have different bridges to your library. That's how I would go about it.
Thank you.
No more questions? All right, thank you.
You're done early. Thank you.